Educating Matt Powell, or at least trying to, Part 2.
We could go. You mentioned the sun was the next one, I think. You mentioned in your video "Evolution is a Fraud" that the sun, correct me if I'm wrong, that some number of millions of years ago, the sun should have been like large enough that it would have engulfed the Earth's orbit, right?
Absolutely, because most evolutionists say that, well, since there's no God, and since we can't have an eternal God, there has to be an eternal universe. And so if the sun is eternal, then obviously the sun would have at some point engulfed the universe.
No.
Absolutely, because most evolutionists say that, well, since there's no God, and since we can't have an eternal God, there has to be an eternal universe. And so if the sun is eternal, then obviously the sun would have at some point engulfed the universe.
No.
Unless you believe. Absolutely, because most evolutionists say that, well, since there's no God, and since we can't have an eternal God, there has to be an eternal universe. And so if the sun is eternal, then obviously the sun would have at some point engulfed the universe.
No.
Unless you believe.
I mean, seriously, did he just say that?
We could go. You mentioned the sun was the next one, I think. You mentioned in your video "Evolution is a Fraud" that the sun, correct me if I'm wrong, that some number of millions of years ago, the sun should have been like large enough that it would have engulfed the Earth's orbit, right?
Absolutely, because most evolutionists say that, well, since there's no God, and since we can't have an eternal God, there has to be an eternal universe. And so if the sun is eternal, then obviously the sun would have at some point engulfed the universe.
No.
Unless you believe in the Big Bang, obviously you could go that route as well. But yeah.
Well, actually, so the thing is, I've never met or heard of any physicist who thinks our solar system is eternal. Right? Our solar system is, as near as I can tell, approximately 4.5 billion years old, right?
Yeah.
But when you actually do the calculations, when you run them, as Vice Strino did, for instance, in his video critique of your video, "Evolution is a Fraud," when you actually run the numbers, you find out no, the sun has never been anywhere near large enough to have engulfed.
I don't mean to cut you off, but I have a question. So basically, how would you measure the rate of burn then? Because they say the sun is burning out at such and such amount per year. How could you possibly, because science has to be demonstrable, testable, and provable, how could you possibly determine what that rate of burn is?
So
I don't think it's possible.
So for what?
Eternal, or the eternal, may refer to eternity, an infinite amount of time or a timeless state, immortality or eternal life. So if the sun was once as big as the universe, first of all, where were all of the other sextillion stars, all those galaxies that we see, all the ones that we see on the Hubble Deep Field, for example? Where are all of those if the sun was as big as the universe? And why is it so small now? Wouldn't that ruin the whole idea of it being eternal? If it's this small now, surely it's going to fizzle out at some time in the foreseeable future. Wouldn't that mean it's not eternal? The current consensus about the age of the sun is, as we can see here, that it's around 5 billion years. Jackson said in the video about 4.5, which is actually in line with what I've heard before, so let's say 4.5 to 5 billion years. And the numbers determined from radioactive dating of objects in the solar system, which are known to have formed around the same time as the sun. Matt also believes that the sun is getting smaller. Remember, he said that at one time it was bigger than the universe. I don't know how that works, but that's what he said. And it will continue to do as it burns up material. Now, I'm going to return to this burns up material later because he doesn't think that it's running out of its hydrogen and helium and so on for fusion. He actually thinks this thing is burning like it's made of fossil fuel. In the future, as it runs out of hydrogen, it's thought that it will become a red giant, engulfing the inner planets. So in actual fact, it's in the future, it's going to get bigger. So what do people think about what it's done in the past? Well, we'll come to that. So 1 astronomic unit is the distance from the Earth to the Sun. So we can see when it's a red giant, it will indeed engulf the orbit of the Earth. But we're talking billions of years in the future here. I would like to know, Matt, where you heard such a ridiculous notion, because you saying it was the first time I'd ever heard anybody say that the Sun was once bigger than the universe. Has anyone out there ever heard anything like it? It just sounds to me like the crazy things that creationists say in order to make their faithful think that atheists are stupid. Finally, a couple of things I found when researching this. First of all, we've got a statement here. Just note here that it says the Sun's about 12.5 billion years, which we've heard before. And it says here, in the last 4 billion years, the Sun has barely grown by perhaps 20% at most. So in other words, scientists seem to think the Sun was actually smaller and is getting bigger, and in the future it will get really big, which is completely the opposite of what Matt is saying. We're also told the surface of the Sun undergoes violent changes on a daily basis. But a group of astronomers found that the size of our nearest star has been perplexingly constant in recent years. In other words, to the accuracy we can measure it, it stayed reasonably the same, and they expect it to fluctuate on a daily basis. The new study shows that the Sun's diameter has changed by less than 1 part in a million over the last 12 years. So we don't know everything about the Sun. This has actually confused the people that are doing these observations. But we're trying to find out more with things like the Parker Solar Probe. As for measuring the rate of burn, we covered that extensively in part 1, and I'm going to keep returning to this because Matt seems to think that the Sun is actually made of coal or something.
Yeah, obviously paleontology, the paleontologists have found that there's...
I mean about the Sun. Continuing on about the Sun.
Okay.
I lost my train of thought. You said the Sun was...
So how do you measure the rate of burn?
Oh, okay.
How much hydrogen it's getting rid of? How do you measure that?
Okay, so that's another... So that actually is... that's an interesting question. I am not a cosmology person, but there are methods, there are telescopes, for instance, that we can use that show us what type of matter other stars and whatnot are made of. It's, was it radio spectrometry, I think is the name of the field?
Yeah, but my question is, how long have we had telescopes for? And if the Sun is burning at that, at that amount per year, we wouldn't have had enough time to be able to make this discovery that they claim to have made, in my humble opinion. So, I think it's a fraud to say, well, we know exactly how much the Sun is burning up when we've only had the telescope for a few hundred years. We haven't had the telescope for that long.
I don't really understand what...
Jackson really makes an error here in talking about telescopes. As we have seen, determining the rate of burn does not require the use of telescopes, and as we'll see shortly, nor does measuring the size. However, he does state that this isn't his field, and he's right about using spectra to find out what stars are made of. It's also the case that Jackson here, having a conversation with somebody like Matt Powell, is being faced with ridiculous claims, and it can be very, very difficult to respond to those just off the bat. If you don't know what sort of ridiculousness is coming, how on earth do you prepare to respond? This discussion was supposed to be about evolution, which is Jackson's area of expertise. What Matt is saying, I'm never going to tire of saying this, is ridiculous. He's fixated on this idea the Sun is actually burning, like it's made of coal or something. Of course, if it actually were, and his model were correct, as it burnt, the diameter would get smaller. But he thinks, because of this model, that the rate of burn is actually measured by measuring the diameter of the Sun, which of course will shrink as it uses up material, according to his model. That's not the actual model. Now, I'm not an expert either, but my understanding is that the diameter of the Sun is a function of the outward pressure caused by the fusion reactions going on at the core and the gravity pulling it inwards. And that's why it's estimated that we'll get bigger in the future, because there'll be less material and the fusion will therefore push it outwards. Now, that's probably simplistic. It may be a function also of the fact that the types of fusion that will be going on, or the elements that will be being fused, will be different in the future. But as I say, I'm not an expert. But even as a non-expert, I can understand that. Matt, it isn't made of coal. So, how do we measure the diameter of the Sun? The diameter of the Sun can be measured with something as simple as a pinhole camera. It's a high school experiment. So it looks something like this. Here's the Sun, pinhole camera, and something to project onto. The idea is that the triangles are similar. So if we say that the projection diameter here is x, the diameter of the Sun is d, let's call this distance y and this distance d. Because the triangles are similar, d divided by big D is equal to x divided by y, and therefore the diameter of the Sun can be measured using x times d divided by y. So we need to know the distance to the Sun, and we can measure x and y because we have the pinhole camera. Now, with this high school experiment, a finer pinhole and a longer distance between the pinhole camera and the projection screen can increase accuracy. But of course, this type of thing is not going to be very accurate. But even greater accuracy can be achieved by measuring the time of transit of Mercury across the disk of the Sun, and Venus as well. The inner planets, from our perspective, will pass in front of the Sun. And if we measure the time of transit, we can get very accurate readings of the diameter of the Sun. Current measurements using these methods are to an accuracy of 65 kilometers. Now, considering the diameter of the Sun is 1.391 million kilometers, an accuracy of 65 kilometers is very, very accurate as a percentage. So, as a percentage, that's the percentage of error. Despite the high accuracy of these readings, Matt could be right that we wouldn't be able to detect the rate of change of radius, not on a day-to-day or even a year-to-year basis. So let's look at that for a moment. So the Sun is losing about 6 times 10 to the 12 grams per second. It currently has a mass of 2 times 10 to the 33 grams. So the fraction of its mass it loses every year is about 10 to the negative 13. This is a very small number. That's 1 over 1 with 13 zeros after it. So because the force of attraction between two bodies is proportional to the masses of those bodies, because the Sun is losing mass, the force of gravitational attraction between the Sun and the Earth is decreasing all the time. And it's estimated that the radius of the Earth's orbit is increasing by about 1.5 centimeters each year. Given that we're sort of 93 million miles away from the Sun, this is a very tiny percentage. So what percentage of its mass is it losing every year? So this is the mass per second in grams, times 60 times 60 times 24 times 365, divided by the current mass, multiplied by 100, gives us 9.5 times 10 to the negative 12%. This is a tiny percentage. Matt thinks that the mass is proportional to the volume. He stated several times that he thinks the Sun will shrink as it burns material. So let's look at that according to his model. So the volume of a sphere, let's say the sun is a sphere to a first approximation, is 4/3 pi r cubed, where r is the radius. If we differentiate that with respect to r, dv dr is 4 pi r squared, which interestingly for a sphere is the surface area. So we know that if the change in r, delta r, is small, that the change in volume divided by the change in radius is approximately dv dr. Now rearranging that and using 4 pi r squared as dv dr, we get that delta r is 1 over 4 pi r squared delta v. And with the radius being so large, note it's in the denominator here, we would have a small rate of change of radius. So if you calculate this, because the r is in the denominator, it's going to be very small. Especially when losing this very tiny percentage of its mass, the delta v, according to his model again, as it loses its mass, it's going to shrink. But that delta v in the numerator there would be very small. So we have a very, very large r in the denominator, a small delta v in the numerator, and therefore overall the rate of change of radius would be very, very small. But in using these sorts of figures, that it's losing this small percentage because it's losing this small amount of mass, I'm not using all of Matt's model yet. And in the next part, we'll look at Matt's model, where he actually thinks that the sun is burning.